How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for covalent bonding and bond polarity and electronegativity. Number one, which scenario is most likely to describe a compound held together by covalent bonds? So you got to remember, covalent is when we're sharing electrons. So which option is this? Well, let's see. One is composed of a metal from the far left and a non-metal. This describes ionic, right? A metal and a non-metal is an ionic bond. Let's see, covalent bonds, solid metal. Nope, those are metallic bonds. One composed of only non-metals. Yes. So when non-metals bond with other non-metals, you can assume that that's going to be a covalent bond. Held together by electrostatic forces. Nope, this is going to be an ionic bond. And then there are no general rules for predicting covalency in bonds. That's not true at all. So when you have non-metals bonded together, you can safely assume that they're going to be bonded covalently. Number two, which molecule has the shortest carbon-carbon bonds? So you got to remember that the single bonds are the longest, double bonds are shorter, and triple bonds are even shorter than that. So if we're talking about the shortest carbon-carbon bonds, we're looking for triple bonds, or if there are no triple bonds, then double bonds. And if we take a look at these options, the only one that has a triple bond is C. Here we have double bonds between those two carbons. Here we have a double bond between those two carbons, single bond right here, single bonds. So it's choice C is the shortest carbon-carbon bonds because there's a triple bond there. A triple bond consists of blank pairs of electrons shared between atoms. Now, things you got to watch out for is if this word pairs is there or not. So triple bond is 3 pairs of electrons or 6 electrons total, right? Pairs are 2. So if it didn't have pairs and it just said consists of how many electrons being shared, you'd say 6, but it does say pairs, so it's 3 pairs. 4, which atom below is most electronegative? So here's the trend for electronegativity. It increases as you go left to right, as well as bottom to top on the periodic table. So let's see which elements we're working with. We got sulfur, we got chlorine, we got Si, we got Rb, and we got Ca. So most electronegative tends to be non-metals. So even just looking at these two metals, you can rule those ones out. Now, most electronegative is going to be to the right. You can see our 3 options are in the same period. So the one that is to the right the most can be expected to have the greatest electronegativity. So choice B, chlorine. 5, which of the atoms below is least electronegative? So again, electronegativity increases going left to right as well as bottom to top. So if we want the least electronegative, we're looking for the bottom left. So we got calcium, magnesium, barium, strontium, and beryllium. Oh, cool. They're all in the same group. So which one is least electronegative? The one towards the bottom. So barium is going to be our best option. All right, a few more problems in this section. Number 6, which of the following molecules has the most polar bond? So you can see they all have hydrogen bonded with some other element. So we're really looking at the electronegativities of hydrogen, bromine, chlorine, iodine, and fluorine. And hydrogen's over here, but the rest of them tend to be in group 17. And the most polar, you want the greatest difference electronegativity. So, you know, which one of these things is the most electronegative? It's fluorine. So we know hydrogen bonded with fluorine is going to give me the most polar bond. Fluorine's the most electronegative element. In the molecule below, which atom has the largest partial negative charge? So largest partial negative charge tells me that it has the greatest electronegativity. So which one of these? Because what happens is, you know, they're sharing electrons, but they're not sharing them evenly, right? Electronegativity is a measure of how much they want to hog those electrons. Fluorine is the most electronegative, so the electrons are going to spend more time around fluorine than around carbon. And then compared to the rest of them, fluorine is the greatest electron hog, so it will have the largest partial negative charge. Fluorine. All right, last one for this section. Given the following electronegativities below, a bond between which 2 elements would give the most polar bond. So you want the greatest electronegativity difference. So you want the smallest bonded to the largest. So if we take a look, which one of these has the smallest electronegativity? It'd be hydrogen. And which of our options has the greatest one? Oxygen. So hydrogen bonded to oxygen will give you the most polar bond. All right, I hope you found that helpful. See you in class. Okay, bye.